We'll go to now to the pressure drop in a straight duct. So we're doing calculation or your ducting, pressure ducting, in order for us to size the capacity or the pan required to develop the pressure, to overcome the pressure. Now, first we're going to introduce the Darcy-Weisbach equation. So we have your equation from Darcy-Weisbach. So we have your change in pressure so we have a change in pressure or your pressure drop on the straight duct. Okay. So that will be your F L over D. Okay. Then you have your velocity squared over 2G. So your L, ang L mo, so that is the length of duct. So it's either meters or feet. Then you have your D, which is the diameter of a duct. Okay. Then we have your V, stands for, so this is also in units of meter or in feet. Then we have velocity, so this will be in meter per second, feet per second. Then your G is for your gravity. So this is 9.8 meter per second squared, or this will become your 32 if I'm not mistaken. Okay. So this is 32 feet per second squared. Okay, so this defines the Darcy-Weisbach. Now for the value of F, so your F, which is yung tinatawag natin friction factor, so from here you're going to we need to use the Reynolds number. So you have your RE, which is equal to your Reynolds number is equal to your density. Okay, so the density of your air multiplied by the diameter of the duct diameter. Okay, then multiply by the velocity of the duct, then divided by the absolute viscosity. Okay, so we have here density of air so this will be kilogram cubic meter. Then we have your duct diameter, then we have your velocity, so this is also in meter, should be meter per second. Then absolute dynamic viscosity. So that is in terms of the unit is Pascal seconds. So we're going to solve your Reynolds number first. You need to determine, in order to get the value of the friction factor, so you need to determine the Reynolds number. So from there, if you get the Reynolds number, so you have to verify what type of flow. So we have two types. So one, if it is laminar, laminar flow. So laminar flow exceed if the RE has a value of 2000, if the value of the Reynolds number is less than 2100. So if it is laminar flow if the value of the RE is less than 2100. Now, so if it is less than 2100, so your friction factor will use the panning formula. So the panning formula is F is equal to 64 divided by your Reynolds number. So yan ang value niya. Now, if the flow is turbulent, flow, your Reynolds number, this is less than, mistake, this is greater than, so less than. So the turbulent flow, so that will be RE is greater than 2100. Now if the turbulent flow, so you will be using your Moody's diagram. So where your Moody's diagram, upload ko rin yan, it will be classified, parang ganito maging itsura ng Moody's diagram if you have your chart diagram. So we have here the curve. So this is a square. Then you have here your relative roughness. Which is equal to your E over D. So this is the diameter of the duct, this is the duct diameter. Okay. Then sa baba you have the value of your dito you have the value of your Reynolds number. Then kung saan sila mag-intersect, so that will be the value of your friction factor. So we have here kung ilan yung Reynolds number na value nakita mo. Let's say you have the value here, so kung saan sila magtama dyan, you have the value versus the relative roughness, you have the value of F. As I said kanina, so ito yung Moody's diagram. So i-upload ko rin yan later on para makita niyo. So we have the value of E, the relative roughness E over D. So ito yun, yung sinasabi ko. So we have here the value. Yan. Then your friction factor here, and you have your Reynolds number here. Right? Now, so for the value of your E, so yung E na ito, sinasabi niya, so this one, okay? So for the value of your E, makukuha dito. So this is already in feet, okay? So you have to convert na lang. So for steel, stainless steel, galvanized, plain, so we have the value low, high, design. I think we'll be using siguro na lang low value type of pipe of surfaces. This is type of pipe, so steel, okay. So we have the value of 0.002 galvanized, plain. So if we have let's do a sample problem. So compute the pressure drop of 30 degrees air Celsius flowing with a mean velocity of 8 meters per second in a circular sheet metal duct which is 300 mm in diameter and 50 meter long. Okay. So we have now your given. So we have your given temperature, which is 30 degrees Celsius. Then we have your duct diameter, which is 0.3 meters. And we have your velocity, is 8 meters per second. Then your length, which is 15 meters. So your equation, okay. So we need to determine down for the Reynolds number. So since we require for the density of air, so not given, so we can use your PBMRT. So we can derive it from here, where your density, which is mass over volume, that will be your pressure divided by your RT divided by mass over your volume, is equal to your density of your air. Where by your pressure, since it is an atmospheric, that will be 325. So this will be Newton per square meter. So divided by your R. So we have your R, which is 287 Newton meter kilogram Kelvin. Then multiply by the temperature, so we have 30 degrees Celsius plus 273 to make it Kelvin. So we have the density of the air of so that is 1.16, okay, 65. Magdugtungan pa natin. So this will be cancel out, Newton, and Kelvin. So we have your kilogram per cubic meter. So 1.165. So we have given now the density. Now let's look for the dynamic absolute viscosity of our air. So what we have there, so the temperature of how much, that is 30 degrees. So we fall in this line. So we have here 30 degrees. So that will be so 18.6. Okay, so we have the given viscosity, absolute dynamics viscosity, that will be 18.6 times 10 to the power of negative 6. So this is Pascal in seconds, Pascal seconds. Okay, so let's compute now your Reynolds number, since all the data were given already. So we have now the equation for Reynolds number. We have your density of air is 1.165 kilogram cubic meter, then multiply by n. So we have the diameter, which is 0.3, then the velocity, which is 8 meters per second, then your absolute dynamic viscosity, we have 18.6 times 10 to the power of negative 6. So this is Newton per square meter and seconds, or this can be expressed as n. So that will be kilogram meter per second squared times your seconds divided by square meter. So to break down, so to cancel out, so we have your common, cancel Newton, nothing common, and meter, so cancel, this will be cancelled out, and this one may iwan, and cancel na doon. Okay, so seconds will be cancelled out. Okay, seconds cancel out, second squared, okay, square meter, will also cancel out. So correct me if I'm wrong, we have the value of your Reynolds number, which is equal to 150,322.58. Okay, so this is the RE now is greater than 2100, so the flow is turbulent. So turbulent, now we'll be using the Moody's diagram. Use the Moody's diagram.